locked to a pipe outside. So just now there was a security lady who asked me to announce it to whoever has it, please remove the Segway. Okay? So yeah, I'll just put it up first. We'll wait until a lot of you are coming. Also, for assignment 3 will be released tonight. Okay, and it will have the same format as your midterm. There will be no MCQ. So audit student, you don't need to come. The rest of you, please come. Well, actually, no. Yes, so the midterm doesn't have MCQ, so the audit student do not have to come. For the rest of you, please come for the midterm unless you have a clash with CS24T or you have any valid reason. The re-midterm will be the next Saturday. Yeah, so for the assignment 3, we had a little bit of problem last sem, which is that if you copy-paste your code into Exemplify, it may not preserve the new line. Okay? But SQL can actually be written as a single line, except for the comments. You know, there's a single line comment where you do a dash dash, and then everything else is treated as a comment. If you want to have a comment, please use the C style comment, which is the slash star. And then at the end, you have a star slash. Okay? I will put a reminder in the question itself. Okay, so we will not be doing this for now. That's lecture 7A. What we'll be doing for now is the end of lecture 6. Remember, we stopped here. Okay, there's a query with universal quantification. Okay, so what does it mean? What does it mean to have a query with universal quantification? For example, you have something like this question here. Find the names of all students who have enrolled in all the courses offered by the CS department. So this part is a universal quantification. What you want to do is that you want to figure out all the courses offered by CS department. Yeah, and it must satisfy all of them. Okay, every student that you want to output must be inside at least one of these. Well, must be inside all of the courses that is offered by the CS department. So that's the universal quantification. If I write it as something like a set, you know, the set comprehension, I can have for all courses C, I can create a set of courses here, is for all the courses C, such that C is C dot, I'll use a dot notation, C dot offers is CS. Okay, so something like this. Okay, or if you really want to have a set or the set comprehension, you can figure out what are the sets. You can do things like, I want all the courses C such that C is in, I believe there is a table called offers, and C dot, I forgot whether there's a DID. If there's a department ID, this must be equals to CS. Okay, so this is a set, the set of all the courses offered by the CS department. Okay? So what I can do is that what I want to find is there's another universal quantification here, is that it must satisfy that for all the courses C1 in this set. Okay? So now you have a set there. You have a set over here. This C will iterate over all the sets, over all the elements in the set. And then given a particular C1, you want to figure out, well, C, the student, or enrolls is actually CID. I do have the relations up there. Okay, so let me create a set more formally. You have the course here, there's a department here, enrolls here. Okay, so to create the set is C such that C is in courses and C dot department is equals to CS. Now what I want to find is that for all the courses C1 within this set, what can I ask? Okay, so C1 must also be inside the enrolls such that if there's a student, the student must be enrolled into this. Okay? So that's the universal quantification. You want to figure out all of this. And how do we do this? Okay, so our analysis will bring us into something. Oh, what happened? Interesting. Oh, okay. Where was I? Okay, so in the query with universal quantification, instead of figuring out that particular set, right, what you can also do is you can find the inverse. Okay? Finding the inverse means that if you have, so if you remember from 1, 2, 3, 1, you want to negate. You want to negate some kind of formula. And if that formula contains a universal quantification, so consider F as for all things, you have a smaller subformula here. Okay? If you negate this universal quantification, what you will have is that this is actually equivalent to there exists a not F. All right? So this is what you can ask instead. Is there exists a not F? Okay? So once you figure out what this formula corresponds to, okay, it's slightly easier. All you have to do is negate that again. You negate the result again. Because what we want to ask is this particular one at the inside for all F. Okay? But what we can easily compute is existence on a not F. So to get back for all F, we just have to negate this. And we will get back for all not F, which is equivalent to for all F. Okay? So this is what we can do. For the mathematicians in you, some of you may already shiver here because we assume that not F is equals to F. Okay? May not be true, especially if you're not working with a classical logic. Here we assume we deal with the classical logic. If you deal with the classical logic, then yes, not f is equals to f. If you don't deal with the classical logic, if you deal with the constructive logic, not f may not be equals to f. Okay? So yeah, there is a little caveat here, is that this f must result into true or false. What do we mean by that? If it's a null, negation of a null is null. It's unknown. Okay? Negation of an unknown is unknown. So then you cannot say that not f is equals to f. Okay, so that's the main idea. Okay? Because if you have a universal quantification, it might be hard to just construct that directly. So we do a sidestepping here. Our sidestep is to negate the condition. Negating the condition, and then we ask for existential. Right? So because existential is easier. Now, instead of just asking for existential, because existential does not actually answer our universal quantification, what we can ask is not exist. Okay, so that's our translation. Not exist is equals to for all. Okay? So again, the transformation is based on this particular analysis by stating that, well, instead of this one is difficult. Okay, because this one is difficult, what I can do is I can say not for all f. Well, again, should be equivalent in the case of classical logic. This one is not exist, not f. Okay? This is the reason why I want you to kind of revise slightly on the CS1231. Because from here onwards, it's kind of heavy in this kind of math. The kind of discrete structures that we are using. Okay, so this is how we answer that particular question. And then if you just insert it into a larger set, a larger query, this is what we will have. This is for a particular fx. Okay, and obviously this is the inside, the f inside. And what we can ask is that this whether or not it exists. So this is from before. The one outside here comes from this one. Okay? The internal query, the query inside corresponds to this. Okay? So that's why, again, universal quantification is a not. So instead of asking for all, you ask not something, okay, or not exist, not f. And that is equivalent. Okay, that's the general idea. The inside one here, as I said before, is how you answer your f, given a particular student x. Okay, is it clear? So yeah, it may come out in your assignment and midterm, so please do practice on that. So that's actually it for the lecture 6. This is everything that can be covered for the midterm and the assignment 3, up to this particular one, the queries with universal quantification. Okay, so obviously not all the questions will be about the universal quantification because you have just learned it today, but you will have some practice. At the very least, you will have practice in the assignment. Okay, so that's basically everything about the subquery. There's basically everything that you need to know about query, SQL query in general, with the exception of that some of the constraints that you need in your ER diagram may not actually be expressible as a query. Okay, for once, our total constraint is not fully captured. Simply as it cannot be captured fully as a relational schema, especially if you have a separate table. What we're going to discuss now is partially about how you can actually enforce many of the other constraints that you cannot do with just a simple ER diagram. We're going to talk about triggers. Okay, so for those of you who came late, so there was an announcement earlier. In particular, the last assignment is important because it was passed to me by the security lady. There's a Segway lock in the pipe outside of the glass door. If it's yours, please remove it. Okay, now the concept that we're going to talk about here is stored procedures, functions, and triggers. So why do we need stored procedures and stored functions? Simple, that's because that's how we implement a triggers. A triggers is simply a very special stored. Okay, so it's Tanwi Teo here? Okay, so it's not ours. Okay, at the very least, I did my job of passing it to you. All right, so triggers here. Triggers here is implemented using a very special stored procedure. The stored procedure or stored function will return a trigger. Okay, you will see how we can construct this later. So this is the recap of the previous one. This is the conceptual evaluation of queries. This is the subquery. Now there's also another thing that stored procedure can handle very easily, and that is transactions. What is a transaction? So this is something that I skipped when we talk about the SQL query. In the previous semester, this was handled when you first talk about SQL query. Consider this. This is the syntax. So a transaction has two outcomes. Whether the transaction is successful or the transaction fails. When the transaction is successful, you end with a commit. When the transaction fails, you end with a rollback. But what is the behavior? When you commit, that means everything is updated at the same logical time, as if they are done at the same logical step. If it fails, you go back to the state before the begin. Right? So this is the important part. You restore it back to the place before the begin. Why is this important? Well, consider these two cases. On the left, you have transaction. On the right, you do not have a transaction. Now, you cannot really, well, I mean, you can obviously update both. You may actually update both at the same time, but in this particular instance, you want to transfer from one to the other. And let's say, for simplicity, the accounts table have a particular check. The check is that the balance cannot be negative. All right? Now, since the balance cannot be negative, this is fine. You can never make the balance negative because you're adding 1,000. Okay, so this one is also fine. The question is, what happens if there is a failure on the second one? Because the second one, you do not actually check first whether there's insufficient balance or not. So let's say this one fails. What will happen on the left? If you start with a total balance in your entire system as 1 million, if this one fails, what you will have at the end is that the entire balance, the sum of all the balance in your system will still be 1 million. Okay, because this one fails, so you do not perform the commit. You go back to the begin, and you roll back every operations that is performed after the begin. Okay, so it is as if this operation has never occurred at all. On the other hand, for this particular one, your balance will be this. You have just given someone an additional $1,000. Okay? Because when it fails here, it only fails on this particular one. Okay? With a transaction, so you have a begin and the commit there. If you have a transaction, then what will happen is that, well, it will roll back everything. Okay? So the actual effect, if there is a mistake in the second updates, will be if you have a transaction, it is as if that entire transaction never happened at all. Without transaction, only that particular SQL code will fail. Okay? So why do we talk about this? Well, one is that, well, again, you have that particular instance. In this example, you have the particular instance where you have a check, and you are not doing the check before you perform the first operation. Okay? You can obviously ensure that the first operation will not go through unless the other party has sufficient balance. Okay? You can construct some kind of more complicated query that allows that. Okay? For instance, you can create the query as, so let me erase everything here. You can also create a query, for instance, you update the account, so set the balance this, where account ID equals 2, and then you also set that you need to also check that the other one, the account ID, and actually no. Yeah, that one is hard. You cannot do it in updatable manners. Okay, so let me think. Can you do it? If you can, it might be a good midterm questions. Okay, actually, you know what? It might be good to have it as a question on midterm. In any case, there is another thing that we need to be careful of, and that is the user of your database may not be one at a time. Okay? It may be multiple people trying to use your database at the same time. So now our problem is harder, because this transaction let's say we can already parameterize this into, instead of just the account ID equals to 2, we say the account ID is equals to some ID 1, and this one is ID 2. Okay? Imagine that this particular query is run by a lot of people at the same time. Okay, and then you can think about the interleaving. Let's give it a name. Let's give this one update with ID 1. All right? Actually, that's not probably enough. Let's call this update plus, because we want to add money to it, with ID 1. And this particular one is update minus with ID 2. Okay, so let's say we have all these operations, Now, this one is going to be used by a lot of people, but at every instances you have a matching pair. You have u plus 2, and then let's say you have u minus 1. So basically 2 sends to 1, or 1 sends to 2. Okay, so that's the meaning. But in between, what might happen is that, well, 2, 1 also, 1 here may also receive something from user number 3. Okay? This one occurs right after this one occurs right after this, before this. Okay, so you can have a kind of interleaving like this. And if in this particular instance, the user with account ID 1 only have exactly 1,000, or exactly 500, let's say, like less than 1,000, right? If user ID 1 have only 500, it will be treated as fail. Because before you actually, this one will be treated as okay. Because this particular instance, user 1 actually received the money first, before it is being deducted. So in fact, even if user 1 has 0 money, it will still be okay. But if there is another kind of interleaving, where you do u plus 2, u minus 1, followed by u plus 1, u minus 3, then this one will fail. Okay, because you try to deduct from 1 first before you actually give 1 some money. Okay? Now, in our course here, we do not really care about this interleaving. What we assume here is that everything will follow the ACID properties. Okay? So that's the good thing about this is that when you go into the real world, you can actually set what kind of a consistency check you want to perform. Okay? Whether you want to perform the consistency check at every single step, or you want to just check it at the end of a transaction. Okay? Because at the end of a transaction, if there is some kind of interleaving, it may be okay. Just right before you do the commit, if the user 1 somehow get the money again, then it will be fine. Okay? There is a trade-off between the speed and the what we call the parallelizability of your code. Okay? The more strict your consistency is, the less parallel operations that you can do. Okay, so what in this particular instance, you don't have to care. Okay, so that's the meaning of these ACID properties. The last time I checked, my SQL did not have ACID. Did not fully pass the ACID test. Okay, I'm not sure about the latest one, but when I was an undergrad, MySQL didn't pass the ACID test. Postgre actually passed the ACID test. Now, what we mean by consistency here is that you must specify constraints. Right? The constraints that we want is basically all the constraints that we specify when you create the relational schema. When you create all the tables, you have all the checks, you have the primary key, you have the foreign key. And then the question is, when do you actually check that? So a particular constraint, when you want to make sure that your database is consistent, you need to perform the constraint check. The check is that immediately after the operations. So what does it mean by immediately after? If, for instance, you have, so we did have this particularly weird table before, where you have a class, and then for a weird reason, our class references ourselves as a foreign key. Okay? This is possible, right? And then it references itself as a foreign key in only that particular attribute. So when you create this particular table, what you have is that, so create blah, blah, blah. You have class here as a, let's say, integer. You specify as a pk, and then you say that it references table T, it references T class. Okay? Class references itself, or table T references itself in the same attributes. So T.class references T.class. We had two possible outcomes for this. If the check is done at the start, you can never insert anything. Right? Because if it is done at the start, there is no value that match your particular foreign key. Okay? So it must start with an empty table. Okay? So you start with an empty table, and then if you want to insert something, if you check the foreign key constraint right at the start before you perform any insertion, then obviously it's going to fail. If you do the checking at the end, then obviously it will always be successful because you are inserting the value that you're going to reference yourself. Okay? Now, for this particular case, it means that if you try to reference your own attributes, if that particular attribute is trying to reference itself, it will always be successful because the constraints are checked immediately at the end. So the value is already going to be there, whatever value you insert. If you insert x over here, x must exist in the table T as the attribute x. Right? And that is trivially true because you just inserted that value. Now, when you deal with transactions, the check is also done at every statement. If you do not want it to be done at every statement, what you can do is you can defer. Defer means that you only check at the end of the commit. Right? And if the check fails, the commit becomes a rollback. Okay, so that's what it means. This one actually consists of two particular keywords. One is deferrable. Deferrable means that you can actually defer the check at the end of the transaction, but you need to have initially deferred as well because initially deferred means what happened at the first operation. The first operation is already deferred. You can have that the first operation must be immediate. Okay, you can read about this online, but let me give you one very particular special case that we can handle with simply adding this particular line. And I already asked this in the tutorial. This is about your circular reference. You have two tables, T1 and T2. T1.a refers to T2.a. T2.a also refers to T1.a. Now here, if you try to insert one by one, it can never be successful because you have this circular reference. Okay? But there is a trick that you can do to make this possible, and that is when you create the foreign key constraint, you cannot create the foreign key constraint immediately. So let's say you want to create T1 before T2, then T1 cannot have foreign key that refers to T2 because T2 doesn't exist. Now T2 can have a foreign key that refers to T1 because T1 already exists, because you create T1 before T2. But what you can do is that, well, you can create both tables first. After you create both tables, then you alter the table in such a way that now you create a circular dependency. Given the circular dependency, can you actually insert something? If you try to insert without a transaction, you will fail. Simply because at the end of that, operations, then you will do the check. Because it's not part of a transaction. But if it is a part of a transaction, when I try to insert this value, okay, so assuming that we start with empty, and I try to insert this value, the constraint check will not be done now. It will be done later. Okay? But when I'm doing it later, at this point, it's already consistent because now I have this value at T2. Okay, so that's the magic of transaction. You can always defer something to the end. Okay, so any questions on this? So how do we create transactions? Now, last semester, I did something very, very stupid, and that is I actually taught the class how to do transaction at the front end. Okay, that is going to be very, very complicated. Now, what I'm going to do now is I'm going to teach you how to create the transaction using stored procedures. Stored procedure is basically functions or procedures, right? And within that procedure, you can have multiple SQL query or multiple SQL code. And the multiple SQL code can have a begin and a commit or a rollback in the middle. Okay? So now if at the front end you want to do something, all you have to do is call that procedure. Your front end will be very, very simple. So this is the history. It's for self-read. There's a little note there about what it really says. There's just a comment from me regarding that particular sentence. This should actually also be kind of a self-read, because what it means is basically that if you already have an if and a while, you can basically create any kind of functions. Okay, what it means is that stored functions or stored procedure is actually Turing complete. You can do weird things with it. What is the difference between functions and procedures? Okay, so why do we have stored procedure and why do we have stored functions? There is one major difference, and that is basically stored functions may have a return type. Okay, you must return something. So if I have a function to add two things, I can accept an integer and an integer, and I return an integer. If I have a procedure, I may not have a return. Procedure mainly deals with side effect. For instance, if you print, the side effect will be whatever you're printing will be displayed on your screen. Okay? So slight difference, but it will be useful later on. Okay, so for instance, for this particular one, the procedure here doesn't have any return. And it's fine, because again, what you want is basically maybe to just insert something into a database. Okay? And so why is it useful? Why do you want to insert something into the database without returning anything? Well, for instance, if you create a new object, there, and you have a total participation constraint, if you realize that the object is new, then you might as well create one in the relationships. Right? You can force it to have a value within the relationship set. Okay? That's one way you can enforce fully the total participation constraint. If the object is not new, you can just simply insert that into the relationship. But if the object is new, you can create the entity and at the same time insert into the relationship set. Okay? And then you don't have to return anything. The example here is basically about that. The functions return something. It converts from miles to kilometers. And it's basically just multiplying by 1.609. It's not as precise, but it's good enough. Okay? But for the procedure, I don't have to return anything. And in this particular one, I'm just going to insert into one, but you can also insert into another table if you want, if it doesn't exist there. Okay, so that's the basic syntax of it. You create or replace. So the or replace can be omitted. It's optional. If you know that you do not have that particular function, you can simply omit or replace. Okay, this is your argument name. This is your argument type. And the return type is given here. The slight difference between specifying the return types and actually performing the return is the existence of a S. That's it. So I don't like the syntax because it's kind of easy to make mistake. Because if you forget that particular S, it may fail. If you accidentally add an S over here, it will also fail. Okay? The language that we're going to discuss mainly is, well, actually only PGSQL. It's a programming language for PostgreSQL. So it's PGSQL. Right? But it can actually kind of run a lot of other language. But I'm not going to discuss that. You can clearly see from this particular example that there may be a problem. The problem is that we're using a quote here. It's the wrong kind of quote, but it should be a single inverted quote. But what happens if we actually have a string in the middle? A string also requires the same kind of quote. Right? And that's a problem, because if I'm doing this, the quote here will interfere with this. And that will give me a syntax error. And so the solution is, well, simple. Just use a different kind of notation. Don't use single quote or single inverted quote. Okay. Now then we may have another problem, right? If you have a function that creates another function, how do you differentiate between those two functions? Because you need some kind of differentiator. So what we can do here is that we can have a set of quotes. A set of quotes can be arbitrary, but it must have a matching partner. Okay, so think about it. If you have this particular quote, it doesn't matter how long you will read the next characters. You treat that as one particular component or one particular token until you find this. That's how we treat a string anyway, right? You find an open quote, you just read everything as if it is part of a string until you find a closed quote. So we need to be able to parameterize this. We need to be able to use any kind of symbols such that we can have a set, a family of these quotes. And that is where the $quoted string comes in. This is the syntax. You have a dollar, you have a dollar, you have a tag. The tag can be anything, like literally anything. How do you read the tag? Well, if you start with a dollar, anything here is considered part of your tag until you find another dollar sign. Okay? Now obviously try not to have a dollar within your tag. Okay? That will defeat the purpose of having this $quoted string. Once you have that, this particular tag is treated as if it is one token, and everything after that is considered to be part of the function. Or this one I should have a semicolon. Okay? And again, everything within that is part of the same statement until you read the closing tag. Now the tag can literally be anything, even empty. So at the simplest one, you can have this. So now if within this function, you create another function, it's safe. Because you can have a different tag to indicate that this is part of the inner function. All right? So that's a family of quotes. So once we have that, once we can create a simple function or a simple procedure, how do we actually execute the function? Now, function must have a return value, which means that you can actually use it as an expression. You can give something inside, and then you are expecting something else in return. Procedure, on the other hand, does not expect any output. Okay, so you cannot use that within an expression. So I can do this. If I create a table that contains two things, one is the name, and the other one is the distance attribute, I can give the distance attribute into this function, and I expect a new value out of it, which should technically give me the correct conversion based on the function that I've just written. Okay? On the other hand, for the procedure, you use a call, because you don't expect anything after that. Now, there's this particularly interesting thing is this. The question is, what is that? That is basically how you denote the apostrophe. That's my string. Okay? So yeah. So that's how you create a function, that's how you create a procedure. And that's how you call a function, and that's how you call the procedure. Right? So then the question is, what can we write? Well, again, like I said at the start, you can have a lot of things. You can have the selection, which is if. You can have a loop, which is something like a while. You can also have a lot of these things. You can declare a variable if you want. You can do an assignment. Now, assignment is using this very special symbol, which is a colon equal. And there's a very good reason for it, because equal is already used. So if you are used to other programming language, typically when we do an assignment, it's something like var equals to something like expression. But this cannot be done in SQL, because equal has already been used for something else, and that is a check for equality. You basically, if you forget the colon here, you're basically checking whether this variable is equal to this expression. But if you have the colon, you're basically assigning it. Now, every declaration must start before the begin. Okay? Otherwise, it wouldn't work. Then what you have also is that you have two control structures, or two broad control structure. One is the if, then else, and the other one is a loop. The if, then else, similar to kind of Python, you have this intermediate one, else if. Well, Python have elif, this one has else if. Right? So again, the condition is very similar. The else if is only executed if the top if or the top else if is not true. Right? And else is executed if everything above it is not true. Yeah, so while, because we don't really use the curly bracket, while must be terminated with a end loop. And in fact, any kind of loop must be terminated with an end loop. Right? So again, the meaning of the while is still the same. You perform the statement. You perform the statement while the condition is still true. Okay, for the for loop, you enumerate all these expressions, and then you perform the inner one, this statement, one by one, where the variable will be equal to the first expression, and then you do it again with a variable equals to the second expression, and so on. Right? There are two special conditions here, is that you can exit in the middle. To exit from the loop, you can just say exit. That will just kind of break out of the loop. The other one is that you can exit only when a certain condition is satisfied, and that's the exit when. Okay, so exit when is not exactly that relevant, because it means that if condition, then exit. Okay, so that's basically what it means. All right. So with this kind of syntax, we can kind of create a lot of programs, but it also needs a lot of other things, because here we haven't really talked about conditions. How do you write conditions, and what other things can you do? Okay, so this is only the control structures. There are simpler operations. For instance, you can have the plus, the minus, and so on. Okay? So you can basically create your programs using this. There are very nice special operators, and that is basically this. You have the square root. It's kind of like your this. Yeah, but you basically okay, that's what it means. The cube root, I don't know how they got it, but it's this. Absolute value is, as usual, is absolute. If it's negative, you just give the positive side of it. Factorial has two types, the prefix and the postfix. The postfix is usual. You can have n factorial. Okay, so fine, that's postfix. The operator is after the argument. There is also a prefix one. You can do this. All right? So not to be confused with a double factorial. There's this thing called double factorial, and that is not exactly what you mean. Double factorial is actually smaller than factorial. If you want, you can look it up in the Wikipedia. You have double factorial is actually n times n minus 2 times n minus 4, and so on. Something weird is going on. Okay, so I don't know why it's called double factorial, but this is the formal definition of a double factorial. Okay, but this is not what it means. Okay, if you have a double bank like this, that's basically a factorial, but you want to put the operator in front, right? Because sometimes it's easier to just read from the front. Okay, so now we can actually start to create functions. Okay, for instance, this is how you can compute distance. Okay, so something very, very easy. I just want to show this particular one. How having this particular operation actually makes things a lot easier. Okay? If you are not sure about the order of precedence of operator, just put brackets all over. Okay? In this particular instance, I'm not sure. Okay? I'm not sure whether if I don't have this bracket, will it still give me the correct thing? My guess is actually no. But in the condition where you have a more stressful environment, like in the exam, if you're not sure, then just put brackets all over it to make things non-ambiguous. Okay? So yeah, now there is one more very fun example that we can do, is that there is actually a random function. A random function generates a random number between 0, inclusive of 0, and 1, exclusive of 1. And it gives you a kind of a floating point value. So why is this fun? Because I guess it's quite late, but if you have watched the Avengers Endgame, or the latest Avengers, or the Infinity Wars, remember there's a snap, right? It kills like 50% of the people. You can actually create that over here. Right? You can have a snap function that, well, just randomly delete things. Right? So this is possible. Obviously, it's also possible without using a function, but it is, if you want to keep on snapping things, you can use a function, right? So yeah, so any questions about this? Okay, so let's have a 5-minute break before we start with the triggers. Yes. No need. There's no MCQ, so final is definitely no need. Yes. Yeah, tutorial, and then assignment 4 there will be MCQ. Because it is okay. Assignment 4 will be on functional dependency, so it will be harder not to use MCQ. No, 2 have. Yeah. Yes. Yeah, please do it soon because before I release the, the solution. Yes. As soon as I finish marking. Yes. For those of you who want to see the fun thing, hey, well, I actually wrote that code. Alright, so it's not here, but let's create a superhero. Varchar 50, primary key, and then let's just insert lots of random names. So insert into superheroes values. I don't know, Iron Man. Spider-Man. Thor. Hulk. War Machine. Doctor Strange. Okay, so let's just say we have this. No, okay, I forgot. Is this single? Okay, so select star from superheroes to give you all the superheroes. Now, if we do the snap, we expect about half of them gone. Okay, so delete from superheroes where random less than 0.5. Okay, so we kill more than necessary. Yeah. Did War Machine survive? Okay, Thor definitely survived, but he's gone here. But yeah, so we get the 2 that was survived. So if you want to use random, you can use it. Okay. In particular, some of the project you can choose if you have multiple candidates for things, you can choose randomly. Okay. If they satisfy certain requirement, then you can just choose randomly. So that's the advantage of having a random number generator. I believe it should be uniformly distributed. Okay, so let's start. Triggers. So again, at the start, there's this all self-read, and what it really says is almost the same because trigger uses stored functions. Okay, again, that's why trigger is a special stored function. It returns a trigger. This is the creation of a trigger. Before you create a trigger, you have to create a stored procedure here, and this is a very kind of special stored procedure that it's actually returning a trigger. Right, so I'm going to show you what it means later, but just bear with me. There is also this. So when you create a trigger, you can specify when does the trigger execute. You can execute before the operations. Okay, so before that. It can be executed before whatever operation you're thinking of. It can be after, or it can actually replace whatever operations you're thinking of completely. Okay? And this is the event. Event is basically things like your update, your insert. So you can have a trigger before every insertion. So you want to check, if I insert this, will it be successful? Right? And then for each row, for each statement, this particular line, it is basically asking when, how many times should this particular trigger execute. So remember, in my example here, okay, it's quite small. But if you see this, when I do the insertion, I can insert 6 entries at the same time. Okay? By inserting all the 6 entries at the same time, it is still considered a single statement. Okay? So it means that, let's put it back here. Where's my, because it is still considered one statement, then if you do that kind of insertion, that you insert 6 values at the same time, the trigger will only execute once. But if you say for each row, it will execute 6 times, may execute 6 times, right? Because you can actually attach a condition. There's this part, when. The trigger is only executed when this condition is satisfied. If the condition is not satisfied, then you won't trigger it, right? And this is what is going to be executed when the trigger is activated. Okay, there are a few things. There are a few special variables that you can use. The more interesting one will be the new and the old. So when you do an insertion, there's no old values, right? Because the old value hasn't existed yet. But there's a new value, the value that you're going to insert. When you want to do an update, there's both the old value before the update, and there's a new value after the update. So you can modify any one of those. Okay? And you can also ask, what is the operations that I'm doing? Okay? And that is this tgop. Okay, so to create a trigger, you need to create 2 things. One, you need to create a procedure or a function. The other one, you need to create the actual trigger itself. The trigger will then be attached to a table. This on this table. Okay? There's a lot of things going on here. The easiest way to go through this part is to give you examples. So let's say I have this table, games, that contains only 2 things, the name and the price. The name is varchar, the price is numeric, and the price cannot be 0. Okay, so first example is there's a condition attached. The condition attached is that I will only perform the trigger. So I will only perform this procedure if the new price is greater than 100. Okay? So when I try to insert something, there's a new. Whenever I try to update something, there's a new. So I can always access the new here. If whatever row I'm trying to insert has a price greater than 100, then I will perform this trigger. If I'm updating something such that the result, the new price, is greater than 100, then I'm also going to activate this trigger. Then I'm just going to raise notice. It will just print. If I use PSQL, it will just print on my PSQL something like trigger 4. Okay? I'm returning something. The thing that I'm returning is a null. Okay, null is your very same null values. However, note that your return type is actually a trigger. Okay? So a trigger is basically a very particular type that consists of the tuple that you are trying to insert, that you are trying to remove, that you are trying to update, as well as all the rest of the special variables. So when you return null, it means that you're going to stop the operation. You're not going to return the next trigger. And because this is performed before any insertion or before any update, you're not going to even perform the insert or the update. This particular one will basically say that I'm not going to insert any games where the price is greater than 100. Because I'm going to return now. Okay? And it's for every row. Okay, so for each row. So even if I insert multiple row within the same code, within the same statement, every single one of them, every single one of the row will be inspected, and it will trigger the, it will activate the trigger separately if the condition is met. Right? Now, what happens if I still want to insert the value? Well, that's the second example. Just return new. Right? Remember, new is a special variable. Right? New is whatever you insert or whatever you update. That is the one that you're going to insert. All right? So what happens if you want to insert something, but you want to modify the value? Here, you're just going to insert whatever value was given to the query in the first place. Right? But if you want to modify, then you have to return the tuple with the exact same structure that you will expect it to. Okay? So here's an example. What I'm going to return is this particular tuple. Right? So again, remember, how does my relation look like? My relation has a name and a price. This one is a varchar. This one is a numeric. I must return exactly that tuple. The value can be different, but the structure must be the same. Then I can modify the value. Now here, what happens if I'm updating or inserting, or if I'm updating any value such that the price is actually lower than the old price, I'm just going to double it instead. Okay? Well, it means that I can never decrease the value of a game. But I'm still going to insert. I'm not going to prevent it. I'm going to insert, but the value that I'm inserting will be different. Okay? That's how you can modify what you are trying to insert. Now, the last one is that so far we have only talked about for each row. What happens for each statement? this is where things get very, very weird. Because for some weird reason, even if you return null, it's going to be inserted. The return is not going to affect whatever you insert. There's a good reason. Right? Your single statement may insert 6 things, but you only activate the trigger once. Then how would you affect all those 6 values? Okay? So if you want to modify whatever it is you're inserting, then you have to use for each row. All right? So if it's for each statement, then you cannot modify whatever it is you're inserting. Okay, so any questions? All of my triggers works on games. So what happens if I have all my triggers attached to that particular table? Well, all of them may be activated, right? What I want to know is, what is the order of activation? Is it based on which trigger is attached first, or is it any other thing? So if you have multiple triggers, the interaction is actually in alphabetical order. And this is where things get complicated, so my suggestion is try not to have multiple triggers for the same table. Because remember that you can actually, if you have a trigger that is activated on insert, you can actually perform anything inside, even an update. And that update may again trigger another trigger. Right? So the interactions can be very, very difficult to trace. Okay? So obviously, I'm not going to test this on midterm. I'm not going even to test this on final exam. You have a lot more things to worry about than triggers. If you want to use triggers on your project, you may do so. Well, in fact, you have to do it if you want to get the full mark. Right? Remember that I have a specification that you need to have triggers. Okay? But you do not need to have a very complex triggers that have a chaining effect. It may be easier to have one trigger for every table instead. Okay, so try to do that. This is an example of how things can get complicated. So remember trigger 4. What trigger 4 is doing is that you prevent any update or any insert. Okay, that's what trigger 4 is doing. If the price is greater than 100, you prevent because you return now. Trigger 2 is that you double the price. Right? But trigger 2 will be executed earlier. So for this particular one, what's going to happen is that if you just have trigger 4 without trigger 2, you will just print trigger 4 less than 100. Is it less than? Oh, new. Greater than. Greater than 100. Okay, so this one doesn't even activate the trigger. Okay, this one doesn't even activate the trigger, but this one activate the triggers because you're trying to update the value such that it's smaller than the previous value. Okay, 50 is smaller than 75. So after this line, the price is reduced to 75, but 50 is smaller than 75. So you will trigger the second trigger, the trig 2. By triggering the trig 2, you will get this one as 150. That's the old price. The old price will be doubled. Okay? Because the old price is doubled, now this will activate trigger 4. Okay? And then you're going to be prevented from doing it. Okay, so that's the trigger interactions. It can be complicated. This one is just 2 triggers. Okay, so that's basically the summary of triggers. In a practical sense, this should be almost everything that you need to know. Okay, because instead of just this, so remember this, instead of just having this particular construct, you can actually write SQL query. You can write the update, you can write the insert. Okay, you can have transactions inside. So that's why we can have things like this. Okay, you can have your store procedure getting triggered by something that is only it will just run an arbitrary SQL query. Okay. So yeah. So it should be. You should technically be able to manage any other constraints that cannot be enforced by the ER diagram in your project. In fact, you should have at least one of those. And the constraint must be complex enough that it cannot be enforced by ER. All right, so any questions? We have one last thing, and that is application development. So again, this is entirely optional because this particular one, I'm going to talk about Node.js with Postgre and with a particular middleware called the Express.js. If your project uses other thing like Python Flask, well, it may not be useful for you. So yeah, so let's take a look at this very basic development stack. In a general sense, every server, well, every application, web application, have these three things. You need the database to store information. You need the library to connect with the database. And then you need the server. The server will handle the request, using the library to connect to the database, and then giving the user whatever they need. Okay, so you get this very friendly general workflow where whatever it is you need to do exists over here. What? For a particular one that we're going to discuss today, the database will be Postgre. The connection library will be Express.js. It has a lot of other things. And the server will be Node.js. So why do I choose this particular one is because if you want to make your website very, very interactive, you need to learn JavaScript. Okay, so that's where the JavaScript library is useful. Which means that instead of forcing you to learn other language, I can just say that your server can be written in JavaScript. Okay, if you hate JavaScript, I will suggest use other things. Okay, like PHP or Python. But I do not want you to get burdened by the programming language itself, that if you want to make it interactive, you need to learn another language separate from your server. This one is very, very nice because your server is written in entirely the same thing as your front end. Okay? So the library will handle this thing. It accepts the connection, and that's kind of automatic. It route if necessary. You can connect to the database, and you need to create and return the response. Once you create, so if you follow the Node.js instructions, then you can actually create this kind of thing. There's a folder structure. This is your app. It can be named anything. But you have the bin, you have the www, you have the node modules, which basically contains all the library that you're using. There's a public-facing static address, which you can use to actually put a lot of other things. There's a routes, there's a views, and there's the main app. So this is the explanation. You can start your app with the npm start. Then it will handle everything. It will start the logging process. It will run your app.js, because that's where your main program is. The routes is typically used to handle whatever page you need to handle. Okay, so you have your main server, right? So typically it will be in the local host if you use a local server. The page means is whatever is after the slash. It can be complex. It can be page 1 / page 2 / page 3. Okay. The one that we're going to discuss is the bottom 3. Okay, and for the very basic one, we'll learn about routing. Okay, so for routing, typically we will use the RESTful API. RESTful API means there's several methods. What I typically use will be just the get and the put. Okay, that's the old one. Actually no, get and the post. The two that I'm typically using will be the get and the post. The main difference between the two is that for the get, you have all your parameters right at the address bar. If you go to Google, you have google.com and then you have question mark, I think like query equals to something. This is your parameter. Everything after the question mark is your get parameter. You can extract those. If it's a post, your parameter will be hidden somewhere inside the header of your request. And if you encapsulate that within the HTTPS, it's secure. You can even transact username and password using the post, because it will not appear anywhere in the address bar. But assuming that you have the HTTPS enveloping all your connections. Okay, so that's the basic one. So the Node.js with the library will just receive the connection, and what you can do with it is that, ignoring everything else, you can send a response. The response that you can send, things like render this particular template with this particular parameter. Okay, so how do we create a template? It will be later. Or you can redirect to another page. Let's say if I'm trying to get into a particular page, but I need to log in first. Then I can redirect that to the main or to the login page. Okay, so that's the other thing that I can do. Obviously, I can do that after I do certain check that the user is indeed not logged in. Okay? Or I can send something. I can send a JSON object. I can send a string. And this is useful if you want to have an interaction between the server and the client without going into a new page. Okay, so if you remember, if you know Facebook, when you scroll too far down, you actually get new, what do you call it, timeline. Right? You get new posts. And that is handled by this send. You interact with the server, and the server will just send you the new content, and then your front end will just basically display that in whatever format you want. Okay? So this is how you can get the routing done. Okay? You get the app.get, so it means that if I connect to this particular page, register, the slash, so localhost register, and I use the get API, I'm going to handle this request using this register handler, which is this function. And what this function is doing is that it's only going to give me some page to display. Right? If it's a post, well, I can do a login checker. This is my intermediate handler. What it's going to do is that, well, I'm going to check if the user is actually authenticated. If the user is authenticated, then I'm just going to, okay, this one is wrong. This is not authenticated. If the user is not authenticated, I'm just going to go into the main page. If the user is authenticated, I'm just going to go to the next here. I'm just calling the next. The next is another handler, and it will be automatically given as this particular one. So I can chain my handler. This is what we call the middleware. Your checker, your login checker, becomes the middleware. To do anything, any other handler after this, you have to pass this handler first. Right, so that's routing. To connect to a database, you need a pool of connection. Okay, there's a slight difference between a client and a pool of client. But what you need to remember is basically this. You need to give these values in your source code. Okay, which means that you have to protect your source code. This corresponds nicely to this particular set. I have this post number, but it's a separate one. It is not actually required here. But this for, oh, sorry, is port. Is port. It is actually required. It corresponds to all these 5. Okay? So you need to remember that. Okay, so you need to remember, the server is typically localhost if you don't host it anywhere. The database is Postgres. The port is 5432. That's the default one. If you don't create any other user, the user will be Postgres. There is at least one user called Postgres. The password, I don't know. It's your password. Okay. If you want to send a query to the database, this is how you can do it. Now, display games here will be your callback. Sorry. Will be part of the, not this particular callback, but it will be your, from the routing, right? So if you have app.get, you have this display games. And that is this particular callback. If you go to a particular page, you can call this function. And this particular function, you can actually have a few things. So the next is if you have the next callback after this, the result will be your result. If you want to send your result to the client, use this variable. What you can do is you can render. Okay, so render as usual. If you want to send your query to the SQL server, you say pool.query. This function will return immediately, but after it returns, once the pool receives the data from the SQL, from the Postgre, it will call this render games, which is this function. Okay, so we're using the callback method. The reason why we're using the callback method is because once you do something, your SQL might be very, very slow. You do not want to get stuck on that. You do not want to wait for the SQL to finish before you can do something else. So what you do is, well, the server will do whatever it needs to do. And once the data is ready, it will continue on with this callback. Okay, so you can chain the callback. This is where things get complicated if you have multiple query. Okay, so yeah, this is about callback. The function returns immediately. If you have multiple query, this attempt will fail, may fail actually, because you are not sure which of this callback will be called first. Okay, it can be that the SQL query 2 is shorter than SQL query 1, so you can actually perform callback 2 before the callback 1. But if callback 2 requires you to know the data about the callback 1, then you're out of luck. Okay, so what you can do is you can chain in this way. Once the first callback is done, you go into the SQL query again, you proceed with that. Okay, then you have the second callback. So you chain. You cannot just simply call both SQL. And this is where the store procedure is easier, because you can just call SQL transaction. Okay? Your SQL query will now become a transaction, or you can simply call whatever store procedure you have. So that makes things a lot simpler to have a transaction. Right? And now, that's about connecting to the database. There's also about how we can display the result. At the very least, you need to learn about HTML. And the reason why I use EJS is because at the worst case, you can always use HTML. It is accepted as a template. All you have to do is change the extension to EJS. But it also can do a lot of useful things. Okay? So at the very least, you don't have any template. Everything is HTML plus CSS. You can pass an argument, and then you can use the argument. To use the argument, there's a special HTML tag, or is not HTML, it's EJS tag, which have this. There's an equal sign there. It means that whatever value, whatever variable you use here, you will look at the value, and then you will use that value instead. So this hello world will be displayed over here, okay, as you can see from here. You can have an if condition. If you have an if condition, notice that this does not have an equal sign. Right? So it's just this. You have if the condition is true, you do this. Otherwise, you do this. Okay? simple if then else. You can have a for loop. If you want to have a for loop, you can do this. This I here will be coming from here. So now you can display 0 up to 9. Now this is where templating becomes very, very powerful, is that you can actually include other templates. To include other templates, there's this particular syntax. There's a dash, there's a minus sign. It means that this particular template will be inserted wholesale into this other template. Okay? So what it means is that if you have common top, you can put it as top.ejs. If you have a sidebar, you can put it as sidebar.ejs. You can include that everywhere else. Okay? If you need to make changes, you need to make changes at the appropriate file. Okay, so that's something that is nice to have. Okay? So that's the very basic of application development. Now, this is something that is, again, obviously entirely optional. If you want to secure your database, there is a possible injection attack. Now, I don't grade on security, but try to make things as secure as possible. This is a very famous injection attack. If you want to verify that someone is in the username password database, you can do this, right? Your query is this. If there exists something, then you can proceed. If it doesn't exist, then you do not proceed, right? So how do I attack this? Well, since you are doing a string concatenation, I can put my string as something like this. My injected code will look like this. Notice the OR here. The username is 0. And this is always true. So I will always return something. Now everyone else can go in without even having a valid account. So how do we prevent this? Well, you need to sanitize your code. Okay? You can do that by removing any inverted code. But there is one very particular powerful way. Okay, so this is the joke here. This actually relates to other things. So if you read XKCD, there's this particular one. The way we can actually make this secure in the context of Node.js with Express.js is that you can use what is called a placeholder. The placeholder is basically a $ with the index +1 actually. It will do whatever sanitization it is needed based on the type of the username. If you're using other language, try to find the appropriate construct to use the placeholder. It is a very common thing, okay? And it is usually enforced by the library itself, either the library or the database itself. Okay? So try not to use your own sanitization method. Placeholder is still one of the best way to prevent SQL injection. All right? But again, I'm not going to grade on this. If you don't have this, it's fine. Even if you store the password as a plain text, I'm going to cry inside a little, but I'll give you the mark, okay? But I'm still going to cry a little inside. Because whatever you do, in whatever project you're going to do, try to make it to be as realistic as possible. Okay? This is to prepare you for the job after you graduate. Right? So try to make it the best possible project by at least trying to think about all these things. For password, try not to keep it as a plain text. You need to encrypt it first, or either encrypt or hash it first. Okay? I will post a link to a GitHub on my little project. Well, actually not really a project. It's something I uploaded to Heroku. And you can actually look at the code for it. It's in my GitHub. I will post the link later today. So if you want to do things like creating a login system, you can follow my format. Okay, if you want. Okay, it may not be the best. I haven't updated it for some time, and I've just got email from GitHub that there's a there's a security problem with the dependency that I'm using. I need to update the packages, but I haven't done so. Okay, so yeah, so this is just to show you what you can do for the remedial. The remedial on this Friday will be from 3 to 6. I will try to go through in the first hour more details about how you can do Node.js. So if you do not want to go for that, you can come at 4. Okay? So I already booked all the remedial from this week onwards will be 3 hours. I already booked them for 3 hours. I'm going to use the first 1 hour to kind of give you some kind of tutorial on how to use Node.js. If you want to use Node.js, you can come. If you do not want to use Node.js, you can come at 4. Okay? So yeah, it's entirely optional to go to the remedial anyway. Right, so if there's no questions, then I'll see you next week. Yes.
So we have to enforce at least one trigger in database. Should we enforce at least one trigger in database for multi-table constraint?
Yeah.
So we cannot check it at the backend, so and reject the service.
You mean front end?
Backend.
No, the trigger will be at the back end.
No, I mean like I use Flask as our backend.
Oh, you mean the server?
Yes, server.
It has to be enforced at the
Database level. So I use this code to if it returns error, then we reject this.
Yes. But you must have one trigger.
So one trigger is enough, or we have to use all like this verification inside the database.
If you want to connect the trigger with your server, it's also fine. So the trigger can return something, right? And if it's returning something, then you can use that return value.
Yeah, but I mean, can I only specify one triggers for multiple constraints, and for other multiple constraints I use server stage.
I think the project requirement is only one.
Because checking a server is much easier. Right.
Oh, 3 non-trivial.
Okay.
There must at least be 3 non-trivial that cannot be enforced and must be enforced using trigger. You can also do it both ways, right? You can have the triggers here, but the trigger is just to make sure that everybody else who use your database will not
Violate the
yes.
But I can also
Yes.
add a server side feature.
Yes. Yes. Right. Probably. So this probably Wednesday afternoon. I'm replacing the tutor for Wednesday because he has ankle sprain. So probably after one. Yeah, I think it's one. I forget when is the Wednesday tutorial. I think it's 10 to 12. My office.
Okay, so after 1 p.m.
Yeah. Okay, sure. Thank you. Yes, not yet. Because apparently they have groups in Exemplify. So I need to actually copy each of the questions individually first before I can create that. So I will upload it. The earliest will be tonight. But I'm trying to get the assignment 3 out first. Because the format kind of should be the same as No, so if there's a fail, there will be a rollback immediately. Yes. Think of it in terms of a procedure. You can have a branch. So at this point, you can have rollback. If it doesn't satisfy certain conditions, you just put a rollback immediately. So here, right, so you can have a begin something, and then at the end rollback. If something doesn't specify, if something doesn't go through, you roll back. You can have it. Yeah, but you can also have a begin. It's the same as begin. Yeah, so every begin must have a corresponding. This one has corresponding end. This one must have either corresponding commit. For every branch, it must have corresponding. If the branch has a corresponding commit or rollback, so it must have a begin. So it must have something corresponding for all possible. Yeah. Then it will just roll. Yeah. No, so this one typically you use a rollback guarded by something. If something rollback. You have a backslash. You have a backslash. This one will be automatically. So this is the input. It's given as an array. So before it is placed here, it will be semicolon. So every it's not apostrophe. Okay, so let's say it's apostrophe. Every apostrophe will be converted into backslash apostrophe. Yes. So this entire thing is treated as a username. It will. Yes. So the or will not be part of the statement. The statement structure will not be. This entire statement has a structure. Right? You select from where. Where doesn't have any end. So the or originally is the statement structure. You select from where or. Then this one, if you do this place over here, you will not change the structure. You will still select from here. The or here is treated